How's it going, guys? Welcome back. Cmake episode 3. This time we're going to be talking about submodules. Submodules are pretty much the coolest thing in the world. This combines GitHub and Cmake to basically allow you to use libraries from GitHub repositories pretty seamlessly, and Cmake has the integration for that. So this is really a GitHub thing. It's just the Cmake integration for it. We're also going to be talking a little bit about options and variables because they're going to be coming up pretty naturally with submodules. A lot of submodules come with options and variables, and you often want to toggle some of those on and off. So it's just it's going to flow pretty well here. All right, so first thing we're going to do is just open the old project we had last time. So I'm going to open my terminal here, and I'm already in the folder, as you can see, and I'm just going to do code dot to open Visual Studio Code with this folder. You can do it however you want. It's just how I'm doing it. And we have the old project we've been working on. There's the top level cmake list.txt, and here is our little adder folder library with that cmake list.txt in there, and the source all the same as before. But now we're going to add another library, except this time we're going to do it with a submodule. You can do this basically with anything on GitHub, just any repo. You can put any repo into your project by, well, submodulating it in. But first we're going to have to initialize this project with Git because this is a GitHub feature. So we'll just do git init on this directory, and there we go. It says we have 46 changes. A ton of these changes are Cmake stuff and C++ building stuff. So the problem with this is a lot of this stuff is not what we want at all. We wouldn't want to push this stuff to GitHub. So naturally we need a Git Ignore is what I'm getting to. So we're going to add a .git ignore on our top level. And we're just going to open Chrome here. And we're going to search for Git Ignore for C++. And we'll just look at the top result. Just kind of want to get some quick answers here to get this Git Ignore taken care of. Copy all that, paste it in the Git Ignore. And we're also using some Cmake, so we'll look for Git Ignore for Cmake, and just grab one of these quick ones. Just grab this text. So this is stuff we just want GitHub to ignore, and we also want to, of course, ignore our build folder. The one that we are using is out/build. Also, we want to ignore everything called a build folder of all capitalization styles. So we'll do it this way: capital B or lowercase b, capital U or lowercase u, capital I or lowercase I, and so on. And then the D as well, and a slash at the end. So we just want to make sure we ignore those build folders. And now, as you can see, GitHub only sees 6 pending changes, and we'll just go ahead and stage these as init. Sounds good. Okay, so the next thing we want to do is start adding in submodules, and to do that you go to your terminal and type in git submodule add, and then the repo directory, and then the folder you want it to go to. If you don't specify a folder, it just goes on the root. So we will go into Chrome here again, and we're on GitHub. Let's just find a common one like glfw3, all GitHub. So this is just a windowing application. None of these are it. Maybe it's just called glfw. Yeah, here it is. So this is a, as it says here somewhere, yeah, it's an open source multi-platform library for OpenGL, Vulkan, and application development. Provides a simple platform independent API for creating windows, context, and surfaces, reading input, handling events. So basically it handles your windowing and events, and it's cross-platform. It's very commonly used along with C++. That way you can get graphics on the screen and use something other than the terminal. And it being cross-platform, super nice because it'll work on Windows, Mac OS, Linux, and maybe other things too. So this is just a great one to do an example of. It also uses Cmake. You can see they have a top level cmake list.txt with a whole bunch of stuff going on. So it'll just fit right in with our project without us having to do much. So we're going to go ahead and grab this URL for the repo. Just that right there, I copied it. Alright, and then we're done here, so we can minimize that. Now I want to go back to my terminal, and we'll we already have this in Git Submodule add, and now we got the repo. And where do we want it to go? We're going to go to external. Yeah, we'll just call it external and then glfw. So that'll clone it as a submodule into external/glfw. That way, if we have multiples, we can go into external and then another name of another library. And we can basically bring in as many libraries as we want. I'm going to go ahead and get glfw configured and up and running. So we added it as a submodule. You'll see it brings in this Git modules folder. And the first thing we want to do is actually stage these changes. This is actually really important. So we'll just say add glfw submodule and stage that. I'm doing it through here, but of course you can do this through the command line too. Git commit everything that's changed, add submodule glfw. So however you want to commit with Git, it's fine. You can do it through Visual Studio Code, or you can do it through Terminal, or you may have another tool. Don't really want to get into Git too much, but just know that you have to stage it. That's actually rather important, or you're going to probably get weird errors. Okay, so now we can go and start setting up our Cmake list. But first, let's just make sure the old version compiles. We're going to just make a few scripts to make this easier. So I'm going to do touch configure.sh and touch build.sh and touch run.sh. That way we can just run these sh files instead of typing our Cmake over and over again. Now we're also going to do chmod plus x to make these ch executable. We'll just make them all like that. There we go. So now we have these new sh files. You don't have to do this. You can keep typing in Cmake commands like I was in the last time. But if you're using Linux, this just makes it a little easier. So first thing we want to do is configure. And basically this is something that will run in terminal when we run this. And our general configure is Cmake, source is here, and the build is where out.build. So that'll just run that command that we were running before, but this time we only have to add /configure. And what this also does is if we add more stuff to this, for example, we're going to add some options for Cmake here in a moment. It'll allow us to just add them to this command here rather than having to remember it in the terminal all the time. We just got to save it in a file. And our build, and this time we're going to change directory into alt/build and then just run make. So that's the terminal line we want to actually build, is just to run that make file basically. And our run is going to be, let's see, we're going to change directory to alt/build again, and then we're just going to type okay, so that should take care of all those three files. Just a little mistake here. We need a slash right here. Yeah, okay. You gotta get it all perfect, or else it won't be interpreted correctly. And now that should run. Okay, so let's go back to our command line, and now let's try the configure. And there we go. Does the thing. Now, just as a reminder, that's exactly the same as just typing that in the command line. Alright, and now let's do the build. And it builds everything. As you can see, it only built the adder and the main. It did not build glfw yet, and that's because we have to configure our root level Cmake list.txt to add it. So we need to add subdirectory, just like we did with the adder, except now it's external/glfw. That's just the path. So now it will build it. So let's go ahead and do the configure again since we changed it. And now when it's configuring, it's going through all of glfw stuff. As you can see, it's looking for Doxygen, it's looking for what display, what, it's a cross-platform configuration. So it's checking what platform we are, using X11 for window creation and all that sort of thing. So pretty cool there. And as you can see, it's building the Doxygen stuff. But if we go look at this Cmake list.txt in glfw3, we'll see that it has options. Build shared libraries, defaults to off. So options are basically just variables you can turn on and off. Build documentation set to on. Install set to on. Bulk and static set to off. So what we can do is we can change these at runtime or at configure time. And the way you do that is you just add it to this command, with a -d in the name of that option. Let me find the name of that option again. Say we want to not build the docs. So we'll copy this glfw_build docs. Go back to our Cmake or our configure, the thing we're going to run in terminal, and it's -d. I don't know why D is option. You tell me, Cmake. /d and then the exact name of that, all in as one word, then equals off. So basically we're turning that option off because it defaults to on. We don't want it on. We don't want to build the documentation. It's just going to take up more build time and extra space. So this is the exact same thing. We just added in this option. So that's kind of how you do options. There's a nice example right there. Yeah, you can integrate that in your project as needed. But also, yeah, pretty relevant for when you're grabbing submodules. Sometimes you don't want every part of it, so you can turn parts off. So let's go ahead and go back into our terminal, and we'll just do the configure again. There we go. And same thing, configuring done. And now let's go ahead and build.sh. This time it is actually building glfw3, build target. Everything else was already built. So the thing about make files in Make is it doesn't build stuff that doesn't need to be built. So since Cmake is making a make file can check if things need to be built based on their timestamp, and it only builds what's needed. You don't have to recompile things if they don't need recompiled. So that's just another feature here. All right, so very good. We've now built it. So we'll find in our out/build, we'll see external glfw3, and we'll see a library in here under source, it looks like. And there it is, live glfw3.a. However, if we want to use this, we still, of course, need to link it to our main and include it. So if we just try to do that, it's not going to work because we need to go include, and then we need the path to it. Now, like we talked about last episode, we need to fix the path. So we've got it added as a subdirectory, but we still need to go target include directories. Let's just add it. So public, now external glfw3 include. Because if we look at it, we'll see that there's an include folder, and that's what you're supposed to include. That's how a lot of open source projects are. Now, if these lines are getting too long, you can kind of separate them and put them on new lines like so. A lot of people do this when there's a ton of them just to keep it clean. That way you can see all the included directories in one line each. Don't have to do that. You can make a big long one too. And the same with link directories here. We're going to need to tell it where the link directory is so it can properly link glfw3. We'll do this one once again as private, and it's going to be external. This link directory is already looking in our build folder, so it paths from here. So we're going to need to go, external glfw3, or not 3, just glfw, and then src, because it's down in this source folder, and then there it is. So that's the right path for that. So we're good there on the link directories, and now we of course need to link the library, and it's just glfw3. As we can see here, you leave off the live part, you leave off the .a part. Cmake knows how to figure that out. All it needs is this middle part. So now we have it, so we can include it easily, and it knows where the library is, so we can link it easily, and we're good to go. We are ready to use glfw3. So let's go ahead and use it. Let's go to our main. We'll go ahead and do include glfw/ what was it, glfw3.h, I think. And we'll leave our old code there. We'll just pop up a window here. So it's glfw window *window. I forget all of this code, to be honest, so I'm going to go actually into glfw3 and into examples. And in here in examples, we'll just look at any of these. And let's look at gears. And let's see, we have a window, we have a glfw init, we need that init, so let's add that. And we'll just add in some more code. Of course, we need this create window. Let's see, and I think we just need a while loop basically, and a terminate after the while loop has left the building. There we go. So there we go. That all right there should do it. Of course, we don't have an animate and we don't have a draw command, so of course we do need pull events and swap buffers. Those are the main things there. So there's some just very basic glfw code. This will just pop up a window until we close it, or it should. So let's go ahead and we'll do configure, then we'll do build. If we get any errors, cannot find the library. So we've got something wrong about this linking. Is it just glfw? Apparently I got it on this one, which is glfw. But apparently we don't need the 3 when we're linking. I don't know. That's a little weird to me. I would think that we would need it, but I must be missing something. So yeah, it actually built correctly. For some reason you don't need the 3 there. Someone could explain that, that would be great, but I thought it only, when you do this, I thought it only thought about, you know, the live and the .a. I'm not sure why it doesn't need that 3. That's so now we should be able to run this, and as you can see, it does pop up a window, so glfw3 is working correctly. All right, there we go. I will upload this and tag this version as video 3, and then a link will be down below, so that way you can review on your own time. All these SH things, as I said, they're totally optional. You can just, you know, you can run the GUI. The GUI basically runs this main command too. So that's another thing I haven't really talked about, the Cmake Gui. It basically runs that same command. You tell it where the source code is, you tell it where you want it to build, and you change the options as you want. It's exactly the same as doing it in this command line. So really no difference there, and that's on Windows. Configure and build with Cmake using GUI, using Cmake Gui, or use command line. Linux command line, easy mode, I'll just call it that. And what do you put? 4 spaces, I think, to make these code type things. Let's see if that's right. Yeah. There's just one more thing, because when you clone this project, it's not going to automatically check out the submodules. So to make it automatically grab the submodules when you start running Cmake, you can actually put in your top level Cmake list.txt, a pretty cool thing that does that. Okay, so one last thing, I want to show you how to use Cmake to automatically grab those repos when it gets cloned. So that way if someone clones the project and then tries to build it, it's not going to say missing libraries, it's just going to go grab the libraries. So normally you do this with Git Submodule update, I think, and init, and then recursive. So normally you just do that and it gets all the submodules for the project, but you can put this right into your Cmake so that it does this automatically when someone tries to build it. And let's see, I've written that previously in another project, so I'm just going to do some copy pasta, and then you guys can use as you want. I think it's all this right here, and I'll walk through and explain this real quick, and that will be the video. Alright, so before we add this subdirectory, we want to make sure we grab the repo. So we'll paste this here. So this is a comment just to say download all submodules. Finds the package Git. Make sure you have Git. If Git's found and your project has a .git folder, then it'll update the submodules. So basically this just checks. You're using GitHub, right? Okay, good. Then it continues, and it has an option here for Git Submodule that defaults to on. So this is another option you could turn off if you don't want it to grab the submodules. But if it's on, which it defaults to on, it's just going to go, hey, it's going to give you a message. So this is another thing you can do I haven't talked about yet. As it's running, you saw all those messages in the command line. You can put your own custom ones in with this here, so you can kind of tell the user what's going on. And now we have an execute process. I haven't talked about execute process either. This basically just runs a command of your choice. So it makes Cmake even more versatile because you can run commands directly from it. So this will run, let's see, the git executable, of course, just git, and it's going to run submodule update and init recursive, which is that same thing I just typed in. And then it's going to save a few things. It's going to do it in the working directory, and it's going to save the result as Git Submodule result. And that allows it to do a check afterwards to make sure it's not false. So, and it gives a fatal error if it was false, and it'll say it failed. So that way it just has a little check. So this block right here just basically downloads all your submodules. And then afterwards, we're just going to make sure the glfw cmake list.txt exists. You just want to do that before you start adding it as a subdirectory. So it's just going to check if not exists, fatal error. So it'll quit right there on a fatal error if it doesn't exist. Otherwise, it's going to continue and add the subdirectory. So it's nice to have this in here. That way when someone else grabs your project and it relies on submodules, it'll just download all the submodules. Pretty cool thing. And that's it. I'll go ahead and save that. The add submodule, pull down, stage that to the Cmake, and go ahead and push that. And now I can push this, but as you can see, it has no remotes. I'll add the remote and post it down below. That way you guys can check out all the source code at the end. Thanks for tuning in. Hope you guys are able to use Cmake and help master level your projects. Get them to where it's easier to work with is really the goal. But this is all making sense. Let me know if you have any questions down below, and I will see you guys in the next episode. Peace out.